Imagine seeing a single atom with your own eyes. Sounds impossible, right? Atoms are the building blocks of everything around us, yet they're unimaginably small. We're talking about something less than a billionth of a meter across. For the longest time, scientists could only observe groups of atoms or infer their presence through indirect methods. But now, everything has changed. A physicist from the University of Oxford named David Nadlinger made scientific history by capturing an actual image of a single atom, yes, just one, suspended in place using advanced technology. It's not a simulation or computer-generated model. It's the real thing, and it's incredibly beautiful in its simplicity. So how did he do it? It started with laser cooling. The atom, a strontium ion, was slowed down to near absolute zero to eliminate motion. This is essential because atoms move rapidly, and to see one clearly, you need to keep it as still as possible. Then, using powerful electric fields between two metal electrodes, the atom was trapped in place. And finally, a highly sensitive camera with a long exposure captured the scattered light from a laser beam bouncing off the atom. The result? A glowing blue dot floating between two needle-like metal structures. That glowing dot is a single atom. And while it looks like a tiny light in space, what we're actually seeing is the light reflected off its electron cloud, not the atom's nucleus. You might wonder, why strontium? Strontium ions are ideal for laser cooling because they react well with the specific wavelengths of light used. They also have multiple isotopes that are useful in various experiments, especially in quantum technologies. What's even more fascinating is the broader impact. This photo won first place in the UK's Engineering and Physical Sciences Research Council Science Photo Competition. But more importantly, it demonstrated the ability to isolate, stabilize, and image a single atom, a major leap for quantum physics. This moment is more than just a cool picture. It opens doors for practical applications in quantum computing, ultra-precise atomic clocks, and incredibly sensitive measurement systems. With this level of control, scientists can start exploring the universe at its most fundamental level, and perhaps one day we'll be able to manipulate matter atom by atom. This one glowing blue dot may seem small, but its implications are massive. From proving what's possible in physics to paving the way for the future of quantum technology, this image is a turning point. This is just the start, my friends. There's so much more to come.